register R contains the value 500, the index register contains the value 100, what must be the address field of an indexed addressing mode instruction to make it the same as a register indirect mode instruction? So here in a register indirect mode instruction, the effective address is equal to content of a register. So within parenthesis R means the content of register. What is the content of register? This is 500. So in the case of register indirect mode, the effective address is equal to 500 because content of register is 500. The index register contains the value 100. In the case of indexed addressing mode, the effective address is equal to index register plus address part of instruction. Index register plus address part of instruction. So now here what is the index register value? It is 100 and address part of instruction we do not know. The question is what must be the address part of instruction in order to make the same as the register indirect mode instruction. That means if you want to get the same operand, the same effective address must be there. So now effective address of register indirect is 500. This must be equal to effective address of register indexed addressing mode, that is indexed addressing mode instruction. So 100 plus address part we do not know. For example, if address part is 500 minus 100, that is 400, then the effective address of indexed addressing mode is the same because effective address of indexed addressing is content is 100, address part is we found it as 400, then effective address is 500, which is same in the register indirect mode also. So that the address part should be 400, then only both will be same. So option A is the right option here. So the following statements is not true. Option A, every regular language is recursive. Option B, recursive language is a subset of recursive enumerable language. Option C, a language L and its complement both are recursive enumerable, then L should be recursive. Option D, every recursive enumerable language need to be context sensitive. So option A, every regular language recursive language is true. We need to find out a statement which is not true. So this we can rule out because every regular language is recursive language is a true statement. We need false statement. Recursive language is a subset of recursive enumerable language. It is also true because in a recursive language we have halting with a final state, halting without a final state, but guarantee of halting. In a recursive enumerable, halt with a final state is there, halting without a final state is there, or looping is also there. That is why the recursive language is subset of recursive enumerable. Option C, a language L and its complement both are recursive enumerable, then L should be recursive. It is also true because if a language L and its complement both are recursive enumerable, then L should be recursive because recursive languages are closed under complementation, recursive enumerable languages are not closed under complementation. A recursive enumerable which is not recursive is not closed under complementation. That is why if any language became L and its complement both are recursive enumerable means it should have been a recursive language. So that's why option C is also true statement. D is a statement which is not true because every recursive enumerable language need not be a context sensitive. It's given as need to be a context sensitive. So option D is the right option.
Two grammars, grammar A and grammar B are given, and in these two grammars we have to find which one is LL1. If we see grammar A, here there is left recursion in this grammar. Whenever there is left recursion, we can say that that grammar is not LL1. In order to be LL1, the grammar should be free from left recursion. So we can say option grammar A is not LL1 grammar. If you see option, if you see grammar B, and if we construct LL1 parsing table for this grammar, there will not be any multiple entries in the table. If there are no multiple entries in the LL1 parsing table, we can say that particular grammar is LL1. So here we will be getting grammar B as LL1. So here correct option is option D. Which of the following sequence will result in strict binary search tree? Here 4 options are given and we have to find out the correct option. A binary search tree is a strict binary search tree if it contains either two children or no children. So let us construct binary search tree for option A. So we will be getting tree as 4. As 5 is greater than 4, we have to insert 5 to the right of 4. And after that we have to insert 2. So 2 is inserted here and 1 is inserted here and 3 is inserted here. So here each node here, if you see the tree, binary search tree, each node consists either two children or no children. Here 5 doesn't contain any children, 2 contains 2 children, exactly 2 children, and 4 contains 2 children. So here we can say this is strict binary search tree, strict BST. Let us construct binary search tree for option B. So 4, next 6 is inserted here and 2 is inserted here, 1 is inserted here, 3 is inserted here. After 3, 5 is inserted. So here 5 we have to insert, for 5 is greater than 4. So it should be to the right of 4. As 5 is less than 6, it should be to the left of 6. So 5 is inserted here. Here 6 contains only one children. So it violates the condition of strict binary search tree. So here we can say this is not strict binary search tree. So let us construct binary search tree for option C. So 4, next 6, then 5, then 7. 7 is inserted here and 3. So 3 is inserted here. And then 2. So 2 after 7, 3, and then 2. 2 is inserted here. So we can say here 3 contains only one children. So which is violating the binary search, strict binary search tree condition. So here we can say option C is not generating strict binary search tree. So let us construct binary search tree for option D. So option D, 4 is inserted, then 5, then 3, and then 2, and then 6. Here both the nodes 5 and 3 are violating the condition of strict binary search tree. Those nodes contain only one children. So here we can say option D is not generating strict binary search tree. So here correct option is option A.